All right. I'll get us started then. I know this is the last session of the day, so I'll be the last one to welcome you here to Community Days, and I'm the only thing standing between you and a happy hour or your own home. So I'll try to get this as quick and as detailed as possible. So I think all of you, I want to ask a question before we start here that you might have never thought about, depending on your role within your business. But once you're told the answer to it, you might go crazy. And that question is, we have how many documents within your business? So today we're going to be talking about some architecting modern document processing. There was already a great talk today on IDP from more of an AI perspective. I'm going to focus a lot on the infrastructure here and the tools that Amazon provides for it. So the agenda today, just going to do a quick little about me section, talk about the different technologies that go into IDP, that being optical character recognition, NLP, and then natural language processing, and then IDP being intelligent document processing. Talk a little bit about why you would even want to do this. Talk about the tools that Amazon provides to actually get this job done. Cover a couple of sample architectures I've worked on, and we'll go through a really simple extraction demo using invoices that I've made up to really show off how this can function for your company. So just a little bit about me. My name is Drake Pocsatko. I'm a senior consultant here in Columbus with Slalom. Slalom, just a quick about us, is we're just a next generation professional services company. This is directly off our website. If you want to learn more about us, feel free to go to our website. I've got a bachelor's in computer science from Ohio State University, a bachelor's in physics from Washington Jefferson College just south of Pittsburgh, which is where I was born and raised, and I've been in Columbus for about 8 years. You can see here over on the side, that's my family, my wife Lauren. It was our 6th anniversary this past Sunday, and my 2 dogs, Badger and Pooch, and our cat Fry. So what are the underlying technologies that actually enable intelligent document processing? These are all definitions pulled directly from AWS's website, so if you want to learn more, there's links provided in the deck. For optical character recognition, known as OCR, that's the ability for software to actually recognize characters in an image or some kind of document and convert those into computer-readable text. We've had OCR for probably way longer than you think. The original OCR softwares were just sort of light pens that you would drag over documents back from in the early 50s, and then it's translated into what we have now, where things with Amazon, you can just upload documents or even just take a picture with your phone and have that just turned into actual structured data in some form. What you can then take with that and actually use is the natural language processing. So say you've got a PDF that's got all these things and you just want to know what the sentiment is. That's where natural language processing comes in. It's a machine learning technology that actually gives computers the ability to interpret and manipulate and comprehend human languages. So things like I had mentioned, like sentiment analysis. Are these emails you're getting, are they positive, are they negative, are they mixed? Detecting what type of language a document it is in. We talked with Darko today, who's from Serbia, who's talking about different results not getting great from Serbia, so maybe a Serbian document, you don't even know what language that is. NLP would help you be able to detect that when it comes in. And when you put that all together with any kind of like sort of other downstream processing, you've got intelligent document processing. And that's just automating this entire pipeline process of taking this manual data entry from paper-based or image-based documents and integrating that output structured data with other digital business processes. So that sounds great. That's all a lot of cool jargon and buzzwords. Why do you want to do this with your business? So a client that Slalom worked with, this was actually my first client with Slalom. I worked with them for about 2 years directly. We'll call them Z. They're a national healthcare payer operating in 48 states. They're a Fortune 100 company. They still use paper documents equivalent to petabytes of data each year, numbering in the billions of individual pieces of paper. And to process all of these documents in all these different states, they have to hire contingent workers to adjudicate, process, extract from all of these documents. There's a huge variance across all these different types of documents, and then also within individual document types, there's variance across locations. Let's say you've got a contract with a healthcare provider in the state of Texas. That's not going to look anything like an explanation of benefits for a member of this healthcare payer in Maine. They are entirely different. You need to have entirely different groups of knowledge to process those. And with these groups of contingent workers across their entire business, there was no kind of templatizing, there was no kind of documentation. It was all based around tribal knowledge, where these little groups would come in, analyze what they had to, and then they would get out. Sounds great, doesn't it? No, it was awful, and the people didn't like doing it, and Z didn't like spending the money on it. let's look at how the IDP solution that we brought to Z actually improved what they were doing. Here's what it took them to manually process one contract, which would average about 40 pages with the states that we were starting with, which we started with Texas. It took about one contract for one human, one entire day, to extract the necessary information, being who signed this document, who is it with, what's the tax identification number. There was a huge list of fields that needed to be pulled from these contracts. And on top of that, for every contract coming through, there's a between 1 in 4, 1 in 5 chance that it's going to have to go through somebody else because somebody got something wrong. And that's just adding more time to this, so you're getting 1 in 4, so day and a quarter, day and a fifth to actually really process this when it comes down to this. With IDP, once we gave them this automated solution, they're processing 50K contracts every single 8 hours with this IDP, and they've got that reprocessing rate down to 7%. 7% being, hey, we've got this document, we think we found the tax identification number, we think it's on this page, can you have someone, a human, do this? So when we output this information into a DynamoDB table, we would leave a list of flags saying, hey, this item needs human review, here's the page we think it's on, here's the value we think it is. So not only are these people getting a document that is either good to go, but when they're not, they know exactly where they should be looking in general to start their process of troubleshooting this and looking for where these values might be. So just an absolute huge improvement. Z was very happy. They've expanded this for many times ever since Slalom has moved on from this engagement within their internal teams, and have loved building on top of this. So cool. How do we actually do it now? We've seen what the outcomes are. Let's build it. Amazon's two main services for this. You've got for OCR, Amazon Textract. For NLP, you've got Comprehend, and then a sort of sub-service called Comprehend Medical, which is more geared towards doing this with medical data. So Textract is, again, the OCR tool here. It has a whole lot more features than just this. This is not comprehensive. When I started working with Textract about 3 years ago, on this list, the only things it had available were form recognition and table detection. So all of these other features are new, and they're adding more and more all the time, especially now with generative AI coming out. They're even building in with other services. So with form recognitions, let's say you've got an invoice, and towards the top of that invoice, you've got a section for address, you've got a section for date. It'll actually return that in the JSON as a key value pair that then you can access here. So you'd see it would show up with JSON, not literally like this. The value within the overall JSON structure would look like this, but I've got Python brain, so I'm going to talk about things like their dictionaries. It would be something like this. Additionally, you can do table detection. So still with that example of an invoice, or we could talk about something like an explanation of benefits where you've got this table that's listing out things, different columns, different values. With the tables, it can actually detect and load those tables as individual table objects that you can then just upload directly into whatever database schema or structure you have. Or if you're using Python, like I love to do, you could even just pull that right into a pandas data frame and interact with the data in whatever kind of processing you're doing. It's also added new features like signature detection. So with signature detection, it's telling you the bounding box location and the page number of where somebody signed something was, and you can see exactly where that is. If you pull it up in the Textract console or at a front end, you can actually even highlight exactly where that signature is to validate that it's a valid signature. Textract also now has support for all sorts of identity documentation right out of the box. So let's say you've got an Ohio driver's license, or you're some company that needs to connect driver's license information. Somebody uploads a scan, you throw it through Textract, it knows exactly where to find anything. You don't need to add anything additional to what Textract has to get the end results that you want. And then a newer feature of Textract that I sadly have not had the chance to use yet, but I'm really looking forward to use in any future IDP projects I worked on, is queries and custom queries. This basically just lets you ask Textract, when you submit a document in plain English, hey, what's the patient's name on this explanation of benefits? Or, hey, what's the due date for this invoice? And based on what Textract pulls out, it can give you that information, and you can access that as part of the output JSON. It'll have the answer to all your queries in the JSON. Additionally, you can train custom queries using things called adapters to sort of expand what Textract is pulling in and figuring out from this data to ask it questions that it might not be able to otherwise understand. I've yet to work with custom queries or queries yet, but based on the research I did for this talk, they seem very powerful, and I'd highly recommend doing some more research on your own if you're interested. Now we can talk about Comprehend and Comprehend Medical to do that second step of an IDP pipeline. This is where that natural language processing comes in. So you've got this big bulk of structured JSON data now. You can get rid of your images and your documents. Don't actually get rid of your source data. So you've got all your JSON here, and then you can, what do you do with it now? It's great. I've got structured data. You can do things with Comprehend Medical and Comprehend right out of the box, like entity recognition, where you can just have it detect PII and PHI entities and tell you here in where list out all of the entities that it found. You can even create custom entities. So let's say you were looking specifically through news articles and you want to identify all of the mentions of public officials. You could provide some kind of custom entity recognition to recognize public officials like Governor Mike DeWine or whomever you'd want to talk about. It could be recognized. You can also do custom classification. So let's say you're a company who's taking in a lot of emails from customers, but you've only got sort of one email address and you want to know where to route these things. You can bring that in and have things like customers who want to know, hey, I want to know about my appointment information. When is my next appointment? Or hey, who do I make my bill to? Using something like this, you can customize those based on your custom needs. You can classify them and actually have them go off to whatever party needs to do those, or then you can analyze them further from there. It also has sentiment analysis and language detection. Like I mentioned earlier, those are two of the bigger and more common features of NLP software. And like I mentioned with Textract, there's a lot more features in this, even more so for Comprehend. The list is ever growing and it can do a whole lot more than what I'm mentioning just here. Now, let's actually look at these being put together with some other AWS services to make a real application that can actually parse your data. So this is my first stab at ever making an IDP application. This is very simple, just very simple. If you were in the other IDP event today, you probably saw a very similar architecture. Basically, you've got your documents coming into an S3 bucket. That S3 notification then goes into an SQS queue for scalability. That triggers this intake function, and that intake function takes the event, parses out the location information of your document, and sends that over to Textract. If something were to go wrong there, we'd send a notification to whomever's responsible for managing this service. And then once Textract's done, it integrates natively with SNS. So as soon as if you're running an asynchronous job, you provided an SNS topic and a role that has access to that, it'll publish a notification when the job is done, be it success or failure. Once that's done, send that message into a queue again for scalability. Then we get to this merge function. What the merge function is, when Textract writes out its JSON output for an asynchronous job, for larger and more dense documents, it breaks those up into a number of JSON files. It breaks up the content into things that it calls blocks, and each JSON file can only have 1,000 blocks. So once you hit that, it'll make another one, and they're all just numerically iterated 1, 2, 3, 4 in an S3 bucket in a folder that's got the same folder name as the job ID for Textract. So this merge function goes in there, takes all those blocks and put them into one single JSON function that allows JSON file that allows you to interact with all the data in one place instead of having to load all these different files every time you want to actually do any kind of processing. Once that's done, we send that to another S3 bucket, got another event here in the queue, and this is where the great modular part of IDP comes in. Once you've done that, you now have structured data. You could do whatever you want with structured data. I'm not a data engineer, I'm not a data scientist. I don't know what to do with structured data, but I've worked with this before and I know some things that I have done with it. So we've got this module here that this could be anything. You could feed your output into a Bedrock model to ask it questions about things coming in. You could feed this into into NLP, like I mentioned earlier, and you'll see in the next sample architecture. You could also even just do a simple extraction using a Lambda function like we'll do in the demo today, where you know exactly that all these invoices are going to have the exact same format. We know we're going to find this table, let's interact with it and get exactly what we're expecting. There's all sorts of different modular things that you can plug and play in with this OCR workflow to make it a full IDP pipeline. Now here's a bit more of a complicated example, but it's still really not all that complicated. If you look closely here, this was a project that we did for a public sector client who needed to redact pretty much every document coming across the governor's desk through the entire state. At the time, they had a single state archivist doing this manually, taking PDFs, taking scans of parchment from years and years ago when the state was first founded, and having to redact things. all of these things were a pain because she still had her original archivist job to do on top of that. So what we built for them was a front end, just a nice little web app for her to go in, upload documents, have them processed by Textract, and then she would get back a PDF or whatever file type that she originally uploaded with black bars drawn over like a fun secret agent document over all of the PII and PHI in these documents. But you'll see after we got to that web application, you're starting to get a really similar architecture here where you go down to this S3 input bucket, to a queue, to a Lambda, to Textract, SNS, SQS, Lambda, bucket. It's the same. The first half of this is the exact same. That NLP process is that simple. And there we can plug that into whatever we want. In this case, we plugged it into a step function that takes that data, we prep it for comprehend, because comprehend in this case was working on text files since it was doing entity detection. So we've got this prep function to do that, and then we check to see if there are available jobs, because comprehend only allows 10 jobs at a time, but those 10 jobs you can have, I think, like thousands of documents in a singular job, but this is just this was an MVP project, so we were just doing one document, one job at a time. So we're iterating, checking for job availability, getting that job availability. Once it's done, we submit, then we're checking in on job status. Is it done? Is it done? Has it failed? Whatever. If it's failed, we go into our failure workflow of notifying whomever, sending the document off to manual review. But if not, there we have the redaction function. The redaction function puts all of this together. It pulls back in that original document from the first S3. It pulls in the Textract output, since the Textract output contains location and bounding box data for all of the things within the document. And then we take the entities that were actually discovered by comprehend. Then we iterate through the Textract to find any of those entities. If we find one, we get that bounding box information, and then we would redact over it in the PDF using a C# library that I do not remember the name of. But then once we were done with that, it would get put out into an S3 bucket, and that would be reviewed by the archivist. If she was happy with it, it went off into whatever deep storage they sent off all of their archived documents in. And then using S3 lifecycle policies, eventually they left the S3 and only lived in the deep archive. So that was a lot, and I am a notorious fast talker, but let's get into the fun part, which is the demo. So this demo is going to be the first half of it, first 90% of it is going to be exactly what I showed in that demo, where you've got this Textract caller function. Oh, I'm not sharing anymore. Let's see. Try to just get back in there. Always fun. Oh, here we go.
Oh, it's again? Okay.
Cool, we're good. Perfect. Live demos, love it. So I wrote this in AWS SAM just because I've done this so many times with SAM. I could probably do it in my sleep. You could do this with CDK. You could do this with Terraform. You could do this with custom CloudFormation. Not the point of this. But basically, we're just creating all the infrastructure that we need here. We've got our caller function here. I won't go too deep into the IAC. You've got the merger function that I mentioned. And here we've got this parser function. What the parser function does is we're taking the data that's coming out of Textract that, since we know what the exact structure of this invoice is going to be, we know every time that we can pull from the table, we can find the row we need, and we can get that information without having to worry about it. In addition to that, we're making our source bucket, our output bucket, the SNS topic, a role for Textract, and a Dynamo table to store all the job statuses, and then also output the information that we actually pull from the invoice. This here is what our invoice looks like. Just a simple invoice from IDP Consulting here. They're charging a lot of money to do manual data extraction. And what we're looking for is to just get the total bill out of this and how much we actually owe to IDP Consulting here. So we can come back to here. I've got my community data source bucket. Upload. Add file. Invoice. Open. Upload. So here we go. It's going to kick off. You'll see that our output bucket here. Oh, that was the output bucket because we're good. I had source open twice. So we've got our output bucket here. So now you see we've got this raw Textract output. Since that was a pretty small file, we're only going to have that one JSON. So we'll click into the job ID here. We've got, here we go, 1. And if it was bigger, there'd be 1, 2, all the way through however many you need. It could be hundreds. I've never had more than 100-ish, but I've also not uploaded an entire novel before. So who knows how big it can actually be. Hopefully Amazon. And now the merge function will have run in the background here, so we can actually check this merged output here. We come in here, same thing, job ID. We've got a folder for the original file name, so that's not lost. And then we've got this output.json. In this case, it's going to be the exact same that one was, but in the event that we had more, there would be this output.json that is the accumulation of all of the other JSON files. Then we can come over to our Dynamo table here. You'll see there's currently nothing in there, but if I give it a refresh, we should have our item here, which, sure enough, we've got the file name being invoice.pdf, the total invoice amount, 1125 that we saw, the actual Textract job ID, the current job status, and then just the output file key of where to find that. That's everything I had for today. We've got about 7 minutes. Does anybody have any questions?
How do you point to that particular value as that is what?
Yes. Yeah. So let's take a look at how we actually worked with this. I'm glad you mentioned that because I forgot to talk about it. AWS provides a Python library called the Textractor. Textractor is a gigantic library that allows for the obfuscation of not only parsing Textract output, but also invoking Textract for synchronous jobs, asynchronous jobs, using different APIs through Textract. I'm currently only using it to process the output, but if you'll see here, let me zoom in just a bit. So I'm getting in the document class through the Textractor. So I'm first downloading that output.json file, and then I'm opening it as a document object. And then within that document, we know that there's only going to be one table. In that one table, we know exactly what we're looking for since this is a standardized form. We then do our convert that into a pandas data frame to make it easier to work with. We do some pandas cleanup to get rid of any trailing white space and any empty rows. Then we're looking specifically for where that description column says total. If we get that value, and then we can go in and write this invoice amount into the database by actually getting the amount from that item. And that's what we're doing to actually parse that table. There's all sorts of different entities that you can use to parse things like key value pairs, signatures, layout information. But for this demo, we just stuck with tables. Any other questions? All right. Enjoy the happy hour.